Today we are exploring our love for physics by looking back at one of the most significant events in science history, the birth of the nucleus. We are talking about Rutherford's alpha particle and gold foil experiment conducted in 1911. But first, let's have a look at what physics really means.
Physics is all about understanding the hidden structure of the world by looking at how things interact. In the Rutherford gold foil experiment, scientists couldn't actually see the atom directly, but by observing how particles scattered, they discovered the nucleus. Our project uses the same idea. We are connecting a basketball hoop to some sensors to model this in a similar way. We can't literally see the exact path of the basketball inside the hoop, but by measuring whether it goes through, hits the rim, or misses, we use that data to work out what happened. That's what makes physics interesting. Simple measurements leading to powerful explanations.
We made a mini basketball hoop out of a celebrations tub, an old lamp stand, some cardboard, and lots of sellotape.
The Arduino Uno is a programmable microcontroller that can receive electrical inputs and respond with outputs from one of its many pins. It is able to measure the length of electrical impulses provided by sensors powered from its stable 5V and 3.3V supplies, and perform calculations with them, or activate other pins programmed to output current.
In this trial, we are displaying a head-on collision with the nucleus, throwing the alpha particle straight through the middle, and this is indicated by the blue light on the panel. The ultrasound waves are reflected by the particle, triggering an electrical signal for the LED to turn on.
We modeled the detection of a partial deflection by using a vibration sensor attached to the hoop. This outputted an electrical signal into the Arduino, causing it to switch on the yellow LED. The hoop acted to model the area of the atom in which the positive charge of the nucleus is able to deflect the alpha particles without a direct hit.
When the alpha particle does not collide or get repelled by the nucleus, it travels through the atom's empty space and is not counted.
Whilst our model of the experiment is on a much larger scale than Rutherford's original experiment in 1911, it effectively demonstrates the results of his experiment on a macroscopic scale in a way that is much easier to view and conceptualize.
Over the centuries, there have been countless experiments which have shaped our lives today. Rutherford's experiment is just one example, but there are many great minds who still continue to discover the future with physics, exploring new technology, practices, and beliefs for all mankind. Physics is the way forward.